Tuesday during class 9. We'll start with chapter 6. And for the final examination, chapter 6, 7, and 8 are included. In chapter 6, we'll learn about series. Now, why do we need series? We will use series. Why do we need a series in an ordinary differential equation first? Any idea? What's our main objective in the course ordinary differential equation? To do what? Solve differential equations. So why should we work with series then? Anything that we learn, it should be linked to our objective, right? So what do you think? We're learning series to do what for differential equation? To solve. Perfect. So our main objective for today is to learn how to use series to solve the linear ordinary differential equation. In order to understand this lecture, we need a little bit of knowledge about power series, and already we took power series in the course calculus 2. We are in the last learning outcome, which is solving linear equations using infinite series, and our objectives are to use power series to find the general solution of a linear ODE. Now, before we go in details about how to solve, we need to recall what's meant by power series, how we add to power series, what do you mean by ordinary and singular points, and then we'll talk about the method to solve, or what's the method of series solution. During this lecture, Miss will cover these parts, and also I will give you feedback on the quiz that was done yesterday. First, what's meant by power series? Let's add this one. X minus 3x, let's say, plus this one, it's what meant polynomial. Which degree? And if you want a polynomial of 100 degrees, it will be, we should have x power 100 something. Now, if you look here, this, what does it contain? X power something. What's the power here? The powers, what are the powers here? Do we have half? Do we have -1? They are positive integers. So the power series, they are the same as polynomial. We have x in it, but the powers are positive integers. But the only thing is that it's what infinite. It means that I cannot say the power series is order 2, let's say. Okay, so in general, the power series is what, like we can have 1 plus x squared plus x cubed plus x4 and so on. Okay, miss? Question before we proceed? And in a power series, we have a center. Like I can write also a polynomial. This one, x minus 1 squared plus 7x minus 1 plus 2. Isn't it a polynomial?
Yes.
This one is a polynomial of which degree? The only difference between the first and the second, let's say x minus 1 cube, I wanted that one, just about no difference in these. Okay, so what's the only difference between them? Here we have x cubed and so on. Here what do we have? X minus 1. Okay, so what's the center here?
Yes.
The center here is x. What's the center? Oh, you mean the center is 0 and here the center is 1. Okay, miss? And in power series, we have the same. So the general form of power series, this is the general form of a power series. We write this notation sigma. What do you mean by sigma, miss? I know that we took that, but I will start as if you forgot or you don't know. So what's this notation, miss? This one is summation. Okay, miss? So let's go back to the power series. If we have power series centered at A, its summation from n equals 0 to infinity, Cn. This Cn that is here. These are scalars. They can be half, they can be radical, they can be negative because they are scalar. X power n, x minus a power n, these ones are integers. So anything power 0, x power 0, and x minus a power 0 is equal to what? 1. So here we substituted n equals 0, what did we get? Only C0. At n equal 1, we got x minus a times C1. At n equal 2, we got x minus a power 2 multiplied by C2 answer. Now, the power series that we will be dealing with in our course are those power series that they are centered at 0. So I need from each of you, after you write the general form, to write the general form of a power series that is centered at 0. So instead of A, we need to write So we want now to write the power series centered at sigma Cn n equals 0 to infinity. Instead of x minus a power n, it will be x minus 0 power n, which is power n. If you want to write it like a polynomial, equals 0, substitute. What will we get? C0 times x power 0. What did we say about x power 0, miss? 1. Then at n equal 1, Sultan?
C1.
1, which is exactly x. So x power 0, we write it 1. X power 1, as Sultan said, we write it as x. Equal to
C2. X minus A. X minus 0.
okay, so x squared, right? Look at it. And n equal 3.
C3. X power.
A, and so on. We find just the first few terms. Now these CIs, can we have them zeros? Yes. Is it necessary that I have a C0 value like 1 or 0.5? I can have it as 0, it's fine. Okay, and this one we call it as infinite series. Why do we call it as power series? Because the variables x, they have powers, and these powers, they are what? Positive and integers. It means that whole numbers. What do we mean by integers? So these and that, they are here. Of course, they are positive because they start with 0. What are the values for them? 0, 1, 2, 3, 4. So what do we call them? Non-negative integers. Non-negative because it's not necessarily positive, it can be 0 as well. Do you have questions? Now, regarding divergence or convergence, in this course, I don't need it, but of course, when we suppose a series solution, it means that we are supposing, or it means that this differential equation is solvable and this series solution converges. Okay? Because if a series does not converge, can I say that series that doesn't converge to a function is a solution? Okay, it doesn't make sense. So all of them, they are convergent. And of course, they are convergent over what? Over the region that is given in the differential equation. Okay, miss? Any questions before we proceed? Now, if you still remember also you took Maclaurin and Taylor series in calculus 2. Here just like to recall, if you look at this series it converges to EX, and this series converges to cosine X. This series converges to sine X, and so on. So basically, these are the ones that I think you memorized them when you were in calculus 2. These are the main things that we have here. At this moment, I don't need them, but just in case we needed them, we already have them. And here, the interval of convergence is over 3 points. Okay. At this moment, we don't want to use them. If we have a question that we encounter and we need them, we will go back to them. Okay, but here just like to remind you that we can write, if we have a function, some of the functions we can write them as a series. And you took them. You took them in calculus 2. Okay, basically you took also this one. This one we can think about it as geometric series as well. Look, for example, at this one. The interval of convergence is on, whereas here the interval of convergence is the open interval negative 1. Okay, so we call what we mean by series. It's like a polynomial, but always we have x squared, x cubed, x4, and so on. We put dots at the end, or we write it as segmentation. Now, the thing that we need to learn now, how to add two series. So we recall what's meant by Taylor series. Now, our main objective is to discuss how we add two pair series. Do we have any questions before we proceed? Let's just try this one in purple. These two pair series that we want to add, they are centered at what, miss? This here. Miss will explain it in detail now. When we are solving the differential equation using series, we will not re-explain it again. So this one is sigma from n equal 2 to infinity and into n minus 1, cn x n minus 2, plus the second sigma is from n equals 0 to infinity, cn x n plus 1. Let's try the question, miss. Give me the first series from n equal
2 to infinity.
n equal 2 to infinity.
And
Okay,
CFX to n
okay.
plus 0 to r. CFX. And
So our aim is to evaluate this sum. Please, all of you stop writing this. Let's go back to polynomials. How do we add polynomials? Let's say we have 3x squared plus 2x minus 5. And here we have plus x cubed minus 2x. How do you add them?
And the coverage.
Same power. So first of all, what's the highest power here? So we will write x cube here. Do we have an x cube here? So what do we say? Right? Plus 1. Then what do we have? X squared. Do we have an x squared here?
3.
So what do we put? 3 minus. Then x. Do we have an x here? And here? Okay, then the constant. Do we have a constant here? Here, do we have a constant? And we simplify. So for the power series, what do we add this variables? What do we add? The coefficients of the equal powers, okay? This is how we add volumes. It means that series, we will add them in the same way. Where's our problem, miss? What's the power of this one? And what's the power of this one? And plus 1. Are they of the same power? Do they have the same power, miss? Look at them. Do they have the same power? Okay, so we cannot add them in this way. So, the first thing, different powers or different exponents. See, please stop writing this. I will explain it anyway. So, what's our A? Okay, I make them same power. It means that I put this, I put like, as if I don't see the n minus 2, I'm seeing it n, and second one, I'm seeing it n. Is this the way that we make it the same power?
Depending on what store, when it starts. Yeah.
Okay. Okay, but suppose here I'm starting at n equals 3. Equals 5, we can have an example that starts at n equals 5. So at this time, what I start with, I don't care at. I care first at same power. Okay. Our aim that we make them of the same power, right, miss? We want to make them of the same power. Suppose that I'm saying integral of x plus 1 dx plus integral of t squared dt. I want to put them under the same t. What do I do? Change off. Must you have integral x dx plus integral t dt. I want them the same integral, to write them under the same integral. So I should give them the same variable. Let u equal x here and let u equal t here and see what will happen, right? Here we will do the same. Where's our problem? The purple part, right? So this n minus 2, we will assign it a k, integer. And this n plus 1, we will assign it a k. And we will change everything to what? To k. Okay, miss? Let's rewrite them again. So what's the step for these ones? To make them the same power, what will we do, miss? So we will assign the power as k. The first one, miss. What do we have the first series? This is our first series. It is sigma and equal to the infinity and to n minus 1 c n x n minus. So the whole power, we will assign it as what miss? K equal and x. Okay, miss? It's in the integral when you say let u equal x. Do you keep having u and x squared and du or dx? What do? You change everything in x to what? To u. So here, Johnny, everything in n, we will transform it to what? To k. This is the main objective of this exercise is to understand. So please do not try it. Just if you want to take notes, it's okay. But we need to understand it because this one, I can start immediately with solving. And we can reach this one. And I will tell you that you have to do it alone because already you did it. But just starting to make sure that everything is clear before we start solving. Because this one, when we are solving differential equation, always we will face this one, and always we will do something known as same power and re-index. So this step is the same power. We started with the first series now, miss, okay? We have two series. If I have one series, it doesn't make sense to change. K equal n minus 2, miss, what does it mean? I need to get rid of what? N. So n is equal K plus 2. Okay, miss? This is the big one. Instead of n, miss, what should we put?
Yes.
K plus, right? Right, miss? Instead of n minus 1,
Yes.
K plus 2 minus 1. I write it in, okay? This and this is also an n. How can we get rid of it? Dk plus 2. And this one is what? X. Okay. Now, what about the limits here? Yes, if we have a proper integral and we are saying let u equal x plus 1, if x starts at 0, you will start at 1, right? Okay, so k equal n minus 2, and n is from 2 to infinity, right? So k, it will be from where to where?
0.
Perfect. K equal 2 minus 2, which is 0, to k. Okay, the infinity doesn't change over 1 because you are doing infinity plus 1, infinity minus something. See, a very large number, I'm removing something from it. It stays a very large number. I'm removing a value from it. Okay, so what are the boundaries now? K equals 0 to infinity. So what's our new series now, miss? This will be our new series. Okay, I will go back again to this one. So here we have two series. Our aim to add them. In order to add them, the first step we need to make them same power. Okay? How to make them same power? The power of the first will assign it as k. Is it clear? Okay. We put the power as k. So everything in n here, we need to get rid of it or write it in terms of k. This is the first step. We wrote it in terms of k, then the boundary, we should also write them according to k because they are written according to. Please write it down. If you have a question, raise your hand. Otherwise, do the second seriousness. Again, our exam 2 is next Tuesday during class time. And the makeup exam, it will be on May 10th, Friday.
Do we change to the same factor or like k equally?
No, the same, because you want them the same power. But here it doesn't matter because it's an infinite series. Can we start with the second series and do these ones? So again, now, miss, we are still in the first step. Please start with the second series. Okay, the second series, what was it? So now the second series. It was sigma 0 to infinity,
CL X or
C and X and plus 1, right? What's the power here? So this is 1. We will take a as K. Okay, miss? K is equal to n plus 1.
how will K be n plus 1 and then n minus 2?
K equal to n plus 1 and n ranges to, yeah, and there, you cannot say K equal n plus 1 here and K equal something here if you don't have the range. So as an integral sense, if I have x dx plus u du, couldn't I take here the same te? Try it, we get the same answer, right? You have boundaries, always you have the right to do that. Limits of integration or limits of series. Now this one is K equal n plus 1. Is that n is equal to what? K minus 1. What will we get? Sigma C K minus 1. Okay. Right, miss? The infinity, is it affected? Infinity, a very, very large number. We're adding a value to it or we are subtracting a value. Is it affected? It will stay infinity. Now, n equals 0. K equal 0 plus 1. So K is from 1 to 50. Okay, miss? Yes. Miss, you wrote this one, right? This one you understood it?
K equal 1.
Yes.
Well,
And Miss, N is from 0 to infinity, right? Let's look at that. It's from 0 to infinity. What's K? So at 0, 0 plus 1. At infinity, adding 1 to a very large number, is it affected? It stays a very large number. Okay, miss? So this is our second series. Questions, Abu Said? So we found our first series, our second series, we made them the same power. Are we done?
you added the
Okay, now we will write and check what we can do. Do you finish writing this? Shams? Okay, you also finished writing, please, miss. Write the two series beside each other. There was a plus between them, right? Okay, write some of them again. So this is the second series and the power series already you wrote it. Done? Okay. What was the first series, miss? The first series after we changed it is K plus 2, K plus 2 minus 1, which is K plus 1, C, K plus 2, xk, and K is from 0 to infinity, and the second one, summation from K equal 1 to infinity, C, K minus 1, xk. So this problem, we solved it, right? Problem 1 is solved. Wasn't that our objective, to have them the same power?
Yes.
Okay, what's the next step? Now we have another problem.
Siblings.
You meant same sorting value. So the second problem now is this one, it starts at K equals 0, and this one it starts at K equal 1. Okay, so what's our second problem now? Problem number 2 starting value for K should be what, miss? Should be the same. In this case, you would choose a Johnny as 1. Why do you prefer 1? Why do you think that should be 1?
One is bigger.
Good. Anyway, so this is our second problem. We need to solve it, right, miss? Think about a way to solve it now. And then we will discuss. Miss, the first one, are you okay with it? The first one having them the same power. Okay, having them the same power, we'll say having them the same exponent. And this one by the index, we are doing the indexing. Anyway, the question about power series is straightforward. It doesn't contain derivatives or antiderivatives or something. It's just dealing with series. So if you understood this part, you will like everything regarding the power series, you will get a whole grade in it. Okay. That doesn't mean that we should have 2 series. If we have 3 series, we'll work with them all stuff. Okay. So now we have 2 series. The first series, it starts at k equal 0, right? And the second series, it starts at k equal 1. So which one do you choose? The larger. It means that if you have a series that starts at 1, a series that starts at 3, you'll choose the 3. If we have 3 series, 2 of them start at 0, and 1 of them starts at 2, we'll choose the 2. Okay? What do you mean by choosing the 2s?
Change the first one.
Miss, if I'm telling you C0 summation, let's say Cn x n equals 0 to infinity. How did we write it? C0 plus C1x C2x squared plus so on. Please let me know if I can write this one as C0 plus. Can we write it in this way?
Yes.
Can we, miss? Okay. Can I also write it can we write it also as C0 plus C1x plus summation from where here 2 to infinity? We can add as many terms as we want, and the one that we reach here, we start with the one after it, right? Now, do we have the right to do that? Okay, what do you suggest to do here in this case?
Get C0 and then.
We have this one starting at 0. So what will we do, miss? Making it at 0, taking the k equals 0, plus taking up from 1 to infinity. Why did we choose 1 to infinity, miss, and not 2 to infinity? Because of this one. So if this one k equals 2, is this one accepted? So we start k equals 0, k equals 1, plus from 1 to infinity. Please take your notes in your own words.
We all take the bigger number.
But we don't eat the small number. We have to consider it as we consider it here, miss. Like when we put it alone. Famous? Okay, miss. So what happens when k equal to 0? We will substitute. Substitute k equals 0. What will you get? What will we get at k equals 0?
2.
Okay, let's try. So 0 plus 2 into 0 plus 1, c 0 plus 2 power 0, right? Plus sigma from k equal 1 to infinity, k plus 2 into k plus 1, ck plus 2 x power k. This one is our first series. Right, miss? Right?
Yes.
The second series, what was it? Plus sigma from k equal 1 to infinity, ck plus 1 or ck minus 1 plus ck minus 1 xk. And this one, it was the second series. Now, do they have the same starting value? Do they have the same starting value now?
Yes.
So now almost we are done. We can write them under the same series.
And now we should have one for this year.
When you finish writing, try to check what will be our final answer list. Oh, so what's the next step? We will get 2c2 plus sigma from k equal 1 to infinity. What's the common between them, miss? What's the common that we can take?
xk.
Xk. What's the coefficient of xk here? What's the coefficient of xk?
K plus 2.
Okay. K plus 2 into k plus 1, k plus 2. And in the second one, what's the coefficient? What the coefficient is that what we have before x over k? Yes. What do we have before x over k, yellow M? What's this one? ck minus 1. So what should we write? Plus ck minus 1. And this will be our final. Is it clear? Abdurrahman?
Yes.
At this moment, they are telling us when we are solving an ordinary differential equation, I haven't explained to you how we solve the differential equation. Yes, we will try to see. But at this moment, we don't know the name. Of course, we know that we will use series to solve differential equation, but we did not do the steps. And why do we have the right to use series in order to find the solution? Questions, miss? Anyways, we'll solve at least 2 questions about series solution and we'll encounter such things in it, so you will be able to understand it. Any question? Now, let's go back to our outline. So we know pair series in general, what we mean by it. We can think about it as polynomial. This polynomial, it doesn't have certain degree. And then we know how to add 2 pair series. So we will summarize for us. This shot. What's the first step to add 2 pair series?
First step is to make the powers.
are the same, and this one we call it as when we have x. So we have here n plus 1 and here n minus 3. In the first series, we'll work with it as k equal n plus 1. The second, can I have in the same series k and n at the same time, Aman?
But you can make them on the.
Exactly. So when we say k equal n minus 1, everything in A, we will write it as k. Now, look, both of them, we have k. What we care about, if one of them starts at 1 and one of them starts at 5, what should we do?
5.
We choose 5, and from 1, we need to evaluate at k equal 1,
2, 3.
k equal 2, k equal 3, k equal 4, and then start it. Evaluation is okay. This starts at 5 and this starts at 5. We will take x power k as common and take the coefficient. Clear, miss? Now we'll move to talk about ordinary and singular ones. Now, why do we need to talk about these ones? Because if the point, first of all, we have a differential equation, we care about the point, a certain point. When we want to find a series solution for it, we need to find the series solution around a certain point. Let's say we want to find the series solution around x equals 0. You have an example, David? We want to double check if x equals 0 is ordinary or singular. Because in order to use or to apply a method, there should be a condition. So we need to understand what's meant by ordinary point and what's meant by singular. Okay, after we finish this one and understand that, we can introduce the method of power series. Now, what do we mean by ordinary and singular point? First, we are talking about second order differential equation now. Okay, of course, for higher order, it's everything is under. The first step is we need to write it in standard form. What do we mean by standard form, Abdulaziz? Before y double prime, what should we have? 1. So if I have x squared before y double prime, what should we do? Divide by x squared, divided x squared or x is not equal to 0. So we first write our equation as standard form. We are saying here x equal a is an ordinary point. This a, it will be given. I will ask you to check if x equal 1 is an ordinary point, x equal 0, x equal 2, x equal -1. So for this one to be an ordinary point, we will look at p of x and q of x. Remember this, if we did not make the coefficient of y double prime as 1, our answer will not be applicable. It will not be, it will be incorrect. Px and q of x, they should be analytic at x equal. Let's please stop writing. Any idea what to mean by analytic? Analytic, this is the percent that will be analytic.
Yes.
Not differentiable.
Can you get differentiate?
We can have the derivative of it, right? So what do we mean by analytic?
Analyze them.
Analytic. X equal a, so this is x equal a. It means that p of x is differentiable at a and in a neighborhood of a. What do we mean by differentiableness? It has what? Derivative. So differentiable, what do we mean by it? Okay. Suppose that p of x is equal to x and q of x is equal to x squared. Differentiable or not? What's the derivative of x? Do we have a problem? What's the derivative of x squared? Do we have problems in that? Okay. So is it differentiable? We don't have problems in it at all. So it's differentiable and it's what? Analytic. Look at radical x. We want to check it at x equals 0. Okay. Radical x. What's the derivative of it?
1 over x.
1 over x is negative 1 over x squared. Radical x, 1 over 2 radical x. Do we have problems in it at 0?
It's 0. Yes.
Okay, so is it differentiable at 0? So is it analytic?
Doesn't have a value x. When you substitute that the graph doesn't have a value.
If it doesn't, 1 over x, it doesn't have a value, so it's meaningless to ask if it's differentiable or not. If it's not continuous, I will not ask about differentiability. But radical x, it has a value at 0, it's 0, right? But the derivative of f doesn't exist at 0. Okay, so is it differentiable? So is it analytic? So when we ask about analytic, it means that as if we're asking about what? Derivative. Okay, miss? Does the derivative exist or it doesn't? Okay, miss? Now, polynomials, do we have problems in them? They are differentiable everywhere, right? So they are analytic. If I have p of x and q of x in the exam as polynomials, will I go and check their derivatives and so on? No need, just I will say polynomials, they are analytic. Okay, miss? Any questions?
Check is differentiable at this point. You said as it has like a little neighbor.
Little neighborhood for analytic.
Yeah.
In the polynomials, will I check the neighborhood? It's everywhere.
But for others, not really.
For others, I will give you. I will give you an example. But basically here we will be concerned about polynomials and rational function. Polynomials, we know the formula for them, we know it. And the rational function now we need to see. Okay, so if you want to take some notes, please take them. Now, if it's not an ordinary point, it means that p of x or q of x are not analytic. What can we deduce, Smith? It's not ordinary. What do we call it here? Singular. Feedback in exam 1. You still can pass by my office either tomorrow, Friday, or on Monday. Monday, you can just take an appointment either between 11 and 12:30 or between 3 and 4. What do you mean by rational function? Ms. Stephen, if you don't know, I know that you know it, but maybe the name of it, you are unable to recall it. Okay, rational function, it means that polynomial over polynomial. Like what this? X cubed minus 2 over x square minus 9. What do we call this one? Rational. Why? Because we have polynomial up and polynomial. Mister, I have radical x over x squared. Is it polynomial? Is it rational function? Radical x over x plus 1, is it rational? Rational? Miss, to be rational, polynomial in the numerator and polynomial in the denominator, is it rational? Why? Radical x is not a polynomial. Okay, miss? Any questions? Now, what do you think about rational function? Or let's look at this function. What do you think about that? Is it analytic? Or at which points it's analytic? It will be analytic at 3. Okay. Where's our only problems here? Denominator. Our problem is in the denominator. So this one is a rational function first. The problem is in x squared minus 9. If I have 0, if I substitute 0, do we have a problem?
No.
If I substituted 1, substituted 1.5, if I substituted 3, I will get 0. I will get undefined. So could it be differentiable at 0? At 3? Minus 3. If I substitute it, I will get a problem, right? So is it differentiable at -3? So where are the places that this function is not analytic?
That's so nice.
It means that when the denominator is equal to 0. So what can we say here? Rational functions are analytic everywhere except when the denominator is equal to 0. Do we agree? So if the denominator is equal to 0, means that our rational function is not analytic. So what can we say about this one? It's analytic. Is it analytic at 0? Is it analytic at 3? Let's just write your notes. We'll give some examples, and for these examples, we'll study them together. Do we have any question for finance? Okay, now let's solve this example. We have here EX, Y double prime, minus 2Y prime, plus 3Y equal to 0. Again, what do we mean by ordinary? P and Q are what means analytic differential. Okay, but we have to pay attention. Is M written in standard form?
No.
So the first step, what do we need to do? How do we know that it's not written in the standard form? What do we have here? EX. So the first step, write it in standard form. Standard forms. How do we get the standard form? We should divide by e power x. Do we have to write to divide by e power x? It's impossible to be 0, right? So what will we get now in u? Y double prime minus 2 over ex y prime plus 3 over ex y equal this. Can we rewrite it in a better form? Can we rewrite? Please let me know if we have to write it as e minus x y prime plus 3 e minus x y equal to. We have to write it this way. 1 over ex is equal to e negative x. So here we list. We wrote it in standard form. It's the next step. Abdurrahman, we need to identify now our P and our Q. What's our P? Okay, everyone. Minus 2 e minus x. Shams, what's our Q x? 3e power minus x. Okay, so this is our P. And this will be our Q. Once again, according the concept of bilateral, all of them are dependent on each other. So hopefully next lecture we finish chapter 6. We only have one method in it, which is we need the series solution around ordinary point. Then we'll start with Laplace transform. Laplace transform, they will be dependent on each other. And the last chapter it will be related to linear algebra with the algebra values in order to solve system of differential equations. Okay. Now, the good thing is that for the final examination, eventually, yes, we don't need any more derivatives or antiderivatives. So everything that we'll solve is just technique without derivatives, without having to find derivatives or antiderivatives. Okay, any questions so far? What's our P? P is equal negative 2e minus x, and Q is equal to 3e minus x. Where is our point? They are asking about x equal to 1. Okay, miss? 2e minus x. They are asking about x equal 1. What do we need to find now? P prime and Q prime. What's the derivative of negative 2e minus x? 2e minus x. Do all of us agree with Ahmed that this is the derivative? Okay. What's the derivative of 3e minus x? Minus 3e minus x. Do we agree with Abdulaziz that this is the derivative? Okay, miss? So let's look at the derivative. Do they have problems at x equal 1? So this is x equal 1. Can we say that they exist at 1 and around 1 as well?
Yes.
So they don't have problems at 1, but also they don't have problems around 1. Do we agree? Do we agree, miss? Okay. So what can we say now about P and Q? P and Q are analytic at x equal 1. Who was asking about how do I check around? You look at the function. It doesn't have problem at 1, but also around 1, it doesn't have problems. Okay? Hmm? So what can we say about x equal 1? Ordinary or singular? No. Ordinary. Perfect.
How much around the function?
I think that's just neighborhood. Either include 0.1 or 0.01. Say around the neighborhood, let's say, what we mean by neighborhood in mathematics is x equal 1. I want to choose a neighborhood with a certain distance. So from here to here and from here to here. When we say analytic in this neighborhood, it means that analytic every point like. Okay, now this neighborhood can be large, means that with radius 5 or 7 or 8 or 100, radius infinity, even here the radius is infinity, or the radius 0.1. Okay.
So the distance itself is the distance.
The main thing is all the points like here. Do we have any questions? Now, is it necessary always distance to be very large? No, if we take, let's say, lim x and x equal 1, can I say the distance can be 5? This maximum can be 10 I reach 1. Because I have 0 and problems are 0. Okay, miss? Any questions before we proceed? Similarly for the tangent x or the secant x or the cosecant x, we do have problems. Okay, miss? So what can we deduce now? Imply that x equal 1 is an ordinary point of. Is it clear? Part 1, yes. That would be part. Do we have any questions for this? Okay, let's look at part 2. What are we asking us? Does have singular points? What do you think? If yes, what are the singular points? And if no, why? So of course, here usually in the exam, I will add justify your ask. Why Abdulaziz? Abdulaziz is saying, what do you think about his answer? Does M have singular points? Okay, so I would say no. Abu Zaid and Abdulaziz said no. What do you think? Okay, why this? Because if we go back here, do P prime and Q prime have problems at a certain point? So E prime and Q prime exist at every real. No. Okay, please not everywhere.
Even if I get infinity.
Real number.
Real.
I said real. Is infinity a real number? Okay. What do you mean by real number? It means that I can say x equal to something and I can know that this is the number. I can put it in a certain box. Even if x equal billions, I can imagine it in a box. But if I say x equal infinity, it doesn't make sense. So the infinity that you are imagining is the same. It's not the same as the infinity that one is imagining. The infinity doesn't have like, I cannot hold it in something. It diverges, okay? So P prime and Q prime exist at every real number. What can we say? Implies that P and Q are analytic at every real number. So it is every real number is an ordinary point for it. We have a touch. Okay. Let's look at these two examples. This polynomial, what's P of it? This polynomial, what's the P for it? One. And what's the Q? P is one. P is 0 and Q is 1. Do we have problems in that? So is it every point is what? Ordinary. 1, what's P and Q? 3 and 2. Do we have problems in that? So it's also analytic. Everywhere it means that every real number is what? Is an ordinary point. Let's look at this one. What's P? Ex. Do you still remember the image of it? Does it have problems? The derivative of n, it's a smooth curve everywhere. Sine x, does it have problems? It's a sinusoidal one and smooth one everywhere. So do we have problems at any point? So every point is what? Ordinary. When we say smooth curve. Okay, I will give you an example of a non-smooth curve. Look at this curve. Is it smooth? Smooth, it means that no sharp ends. Is there a sharp end here? Okay, so it means that this one is not analogy everywhere. Where is the problem with the differentiability? Okay, additional. Okay, so this is what we need. Now, in our minds, Ex, sin x, sin x, is there any problem in that? They are analytic everywhere. Okay, miss? Any questions? Polynomials, do we have problems in that? Constant functions are special case of polynomials. So constant functions, do we have problems in that? Constant, 3, 2. Okay, miss? Okay. Let's look at this example, miss. What's P? Okay, Q. Do we have problem in Q? Where's our problem? Okay, 1 for x is a rational function. Where is our problem in the ordinary? At x equals 0. So everywhere, every real number is ordinary except what? X equals 0, it will be what? Singular. Okay, miss? Here, miss. Miss, we will solve about that point, but we are just looking now. Okay, miss? Let's look at this one. What's P? What's Q? Do we have problem in P? In lim x, where's the problem? Just at 0 with both -1 and -2. So do we have problems after 0? So every point, every real number after 0 is what? Ordinary point. Okay, miss? We'll put an example on Okay, what do you think about something this one and then putting another example? Let me just write the example. We will do this example before, and then I will go back to the next one. What's the question here? They are not asking to check if a certain point is ordinary or singular. They are giving us a differential equation, and they are asking us to find all its singular points. Is this differential equation written in standard form? First, what I need from each of you to do is write in standard form. Write the equation in standard form. When you write it in standard form, what's your premise?
So,
And what's your Q? Right, miss? Did all of us know how to find P and Q? So again, P is 2 over x squared minus 1. Q is 6 over x squared minus 1. What are these terms? What does it mean? Analysis at every real number except when, in this case, x squared minus 1 is equal to 0. Why did we write x squared minus 1 equal to 0? Because this is our what? Denominator. Right, miss? Okay. When can we say that x squared minus 1 is equal to 0? X plus or minus 1. So how many singular points do we have? And every other point, it will be what? Ordinary point. Okay. So for example, x equals 7.5, it will be what? Ordinary or singular, miss? Ordinary. Any questions before we proceed, miss? Did we finish writing this one, miss? Okay. So what did we use here? X equal plus or minus 1 are the only singular points. All the rest real numbers are ordinary. Any questions? Okay, so if you finished writing, did we finish writing? I want from you to solve this example. So let's take a few minutes to solve this one, and then we will discuss. Please first identify your P, your Q, and then check the differentiability and whether it's analytic or not.
Open the pocket or you recommend to the pocket?
So open?
To open the pocket.
No.
Okay.
Or if you have no longer, you will of course keep it this way. It's easier. Okay, yes. So what's our P? P is equal to x over x cubed x squared minus 9 x squared plus 1. And what's our Q? What are the times, these ones? Rational function. So both of them are rational function. Okay, who would like to share their answers? What are the singular points that you find? Okay, so Amr and Ahmed got 0 plus or minus 3 only, right? And the other plus or minus 1 also?
Yes, this is 11.
X squared plus 1 equals 0. Is it solvable in R? In R. Can you say x squared equals -1 in R? Yes, we are finding here the singular points over the real numbers. So x equal plus or minus I don't care about that. Okay. Okay. So P and Q are rational. Analytic. Everywhere except at which ones? So what are our singular points? As we have to say, except when the denominator is equal to 0. Which is x equals 0, x equals +1. Any questions so far? So let's go back to our main objectives. We talked about pair series in general, how to add two pair series by re-indexing. We also talked about ordinary and singular points, the difference between them. Okay, miss? Any questions so far? Now, let's have the method of pair series. We will do just an introduction. After this introduction, we'll go to the quiz and give feedback on it. And after it, if we have time, we'll go back again. So the pair series method, if we have a differential equation of this form, y double prime plus p of xy plus p of xy prime plus q of x equal 1, and x equal x1 is an ordinary point. So if it's a singular point, I cannot apply the power series solution method. Then we can apply the power series solution method. We can find two independent solutions by substituting instead of y summation 0 to infinity Cn x minus x. So if x equals 1 is an ordinary point, we can have power series solution of the form sigma Cn x minus 1. And if we have x not equal -1 as an ordinary point, we will have sigma Cn x plus 1 power n is a series solution. Okay, if x equal 1 is a singular point, can we write the series solution in this way? We can. So it should be what, Miss? Ordinary. Now, what if it's singular point? We'll talk about it. Now, mainly we care about when x equals 0 is an ordinary point. So mostly our questions will be when x equals 0 is an ordinary point, and we are finding a series solution around what, Miss? X equal to 0. So what will be the series solution around x equals 0? So if x equals 0 is ordinary point, how do we write y? Sigma n equals 0 to infinity, and here c and x power. And all our questions will be related to this part, where the ordinary point is x equal to 0. Is it clear, Miss? Do you have a question, please?
You have to delete it.
At this moment, I want to explain step by step. Do we have any questions so far, Miss? Oh. Let's say x equal 0, ordinary point, or it will be singular point. Okay. It is an ordinary point. We will have a series solution. Y equals sigma Cn x power n from n equals 0 to infinity. Okay. Now, if it's a singular point, we will have, please don't try it. We will have either irregular point or regular. If it's regular, we will apply something known as convenience method, which is also series, but not in this form. It will be summation Cn xn plus r. Okay. Now, this is in general the series solution method. But what we are concerned in this course is about what? The one that I will highlight. When x equals 0 is an ordinary point, so we will write the series solution in this way. But just I'm putting for you a slide, just like in case you encounter something that it's not an ordinary point, it's a singular point, and they solved it using a series. Yeah, they solved it using a series, but they did not take this one. They will take instead of it, I will write it, but it's not like related. It will not be given in the exam. So convenience method, we will write here n equals 0 to infinity Cn x power n. So what's the difference between these two methods? Here, what do we have also? X power. Okay.
Can you write the theta? Can you write the theta?
Can we run?
Can you write the period on the slide so you know because
Yeah, no. Let's not need it in this course for the exam, but in your, let's say if you're solving a differential equation, maybe you will encounter it. But anyway, it will be the same method as this one. It's easy. The idea now, if it's an irregular point, we can apply the series, okay? The series function. So only this green part is highlighted. Any questions so far, miss? So mostly all our questions will be around x equal to 0. So if x equals 0 is an ordinary point, then we can have a series solution of the form y equals sigma Cn x power n from n equals 0 to infinity. Johnny was telling me we should differentiate it. Why? We have a differential equation. So in a differential equation, we have y prime, we have y double prime. So what do we have here? We have y equal sigma. So what do we need to find? Y prime, and what do we need to find? Y double prime. Miss, y is a series, right? C0 plus C1x plus so on. What's the derivative of this one? C0, it becomes the C0 is what? Is a variable? It's a constant. So what's the derivative of it? 0. So we will get C1x plus 2C2 and so on. So basically here what are we getting C and x power n, it becomes NC and x and minus 1, right? Miss, what's the derivative of x power n? Okay, but here if you look, we started at what? 1. Why didn't we start it at 0? It doesn't exist, okay? Now, y double prime, x and minus 1, its derivative, it will be n minus 1, x and minus 2. And we will start it at what? N equal. If I want to find y triple prime, I will start it at n equal 3. Okay? These ones, in every question that we solve it as power series, we will find y as sigma c n x n, y prime in this way, and y double prime in this way. We know how to differentiate, but in case you forgot, you can just memorize these.
does the n have to be 0? The y for y does the n have to be 0? The n equals
Yes,
0.
and it should start with 0 because you have C0. Do we have any questions? So we are differentiating. If we are differentiating F1 plus F2, so the sigma will be separated as 1. Okay, miss? Please write it down.
So that it's on which. How do we know that it
If y starts at 0,
starts you?
y prime, where should we start?
One,
Y double prime, 2,
three.
3. Okay. Any questions, Nas? Any questions please before we proceed? So again, if it's an ordinary point, then we can find a series solution of the form y equals sigma c n x n. We should find y prime and y double prime in this way. So these ones, they are applicable to every question where x equals 0 is an ordinary. Any questions before we proceed, miss? Now, we'll go to the quiz. I will give a feedback on that. And then if you have a question regarding our examination of next Tuesday, we'll answer it. Otherwise, we'll go through back to our method in order to see. Let's look at question number 1. We have a fifth order differential equation. So they are giving us a fifth order auxiliary equation, right? We need to find the general solution of that. So here, if we want to solve this one, we will get M1 equal M2 equal to 0. It cannot be coming from my slides. This is the maximum speed. Okay.
You do the count.
Hmm?
Because you're not using count, man.
I will consider using crop. Okay, so we will get C1 plus C2x from M1 equal M2 equal 0, right? Then M minus 3, it gives us M equal 3, so we will get E3x. And x squared plus 25, we will get M equal plus or minus 5y, which gives us cosine 5x and sine 5x. Yes, you can join the meeting through Teams online, and you will see it in front of you. It will be better, okay? You can screenshot the question as well. So what will be our correct answer? The first one. I will wait a little bit so all of you join and you can screenshot your answers. Did you screenshot the first one? Is it clear, miss? At least just mute it. Okay, so let's please mute. Let's look at the second one. We are given a sixth order linear differential equation with constant coefficient. So instead of y power 6 as derivative, we will put m power 6. Of course, here the substitution is a power mx. And this one, minus 3m cubed plus 5m squared minus 8 equals 0. I expect that all of you solved this one correctly. Is it the case? Now, this one is, we are already given the solution of the homogeneous differential equation. And we are given a non-homogeneous differential equation. We need to find the particular solution of it. Okay? Let's look first at Ex. Do we have here Ex? So, constant times Ex, we should multiply it by what? By X. Sine X, sine 3x. Do we have anything related to sine 3x here? So we will just write in a sine 3x and cosine 3x with a constant. Okay, miss? Now, regarding 5x, do I have an x here? 5x, we write it as ax plus b, right? Ax plus b, but we have x, so we should multiply by x. If we multiply by x, we will get ax squared plus bx. Again, we have x again, so we should multiply by x. Another time, we will get ax squared plus bx cubed. Is it accepted? Why is it accepted? Independent with the homogeneous solution. Clear, miss? This one, did we solve it correctly? If you want to take some notes, please take them. Let's look at this example. We are given the general solution, and we need to find the solution of the non-homogeneous one. If you look at the non-homogeneous one, it's equal to x plus 3. So the particular solution will be of the form ax plus b, right? And we should substitute. After substituting, miss, we will get ax plus b, a 2a plus ax plus b equal to x plus 3. Right, miss? So what will we get now? We will get A equal 1 and B is equal to 1. So this is the particular solution, and already we are given the general solution, right, of the homogeneous part. So it's YH plus YK. This one, did we solve it correctly? Let's look at question number 5. The method of undetermined coefficients can be applied to this one. Could it be? To apply the method of undetermined coefficients, we should have after the equal one of the forms that we discussed before. And what should we have? Linear with constant coefficient. Here we don't have problems in what we have after the equal. Where do we have problems? Non-linear, but with non-constant coefficients. So the answer here is false. By the way, if you want to solve this one, what's the easiest method? Variation of parameter. Now, this one is, they are giving us a non-homogeneous differential equation, right? Can we apply for this method undetermined coefficients? It's linear with constant coefficients, right? But can we apply the undetermined? Why? Because after the equal, what do we have? The form of the function is none of the forms that we can apply the undetermined coefficient. So here, which method should we use? Variation of parameters. But they are already giving us U1 and U2. So it's U1, Y1 plus U2, Y2 plus the homogeneous solution. Okay? Now, in the exam, if we want to solve it, first we will write it in standard form. Is it the case that it's in standard form? Yes. The second step, we need to identify our f of x. We need to find W, Ranskin, then W1, W2. Then we need to find U1 prime, U2 prime, which is W1 over W and W2 over W. And then we will integrate U1 and U2 and substitute Y equal YH plus YP. Any questions, miss? Any questions related to the exam? Okay, so let's go back to our. Okay, so now we need to discuss the power series solution method. The first step, we need to make sure that it is an ordinary point. Then we will write the solution as y equals sigma Cn x power n. Then we will find y prime, the pink one, y double prime also the pink one. It's a solution list. So what will we do now? Solution means that, what do we mean by solution? If we substitute it, we will get left equal right. So what's the next step in this now? Substitute. So the method one x equals z is ordinary. 2 y equals sigma Cn xn from n equals 0 to infinity. Y prime, y double prime, write them as series. Okay, miss? Then 3, substitute in the ODE. When we substitute in the ODE, we will get sum of series. Okay? So when we substitute, we will get these ones. Sigma plus something equal to something, equal to 0. Right, miss? What do we need to do? These sigmas, we should have them same power and then same starting. If you look here, the only place that we use the derivative in it is which one? The second one. Plus here, we are not doing that derivative. We can just memorize it. It's not about memorizing. It's just x n is n x n minus 1, x n minus 1 is n minus 1, x n minus 2. Okay, miss? Do we have any questions? Okay, we will not solve this one. I will just go through this test, what we will do. Look at this one. Do we have problems at x equals 0? So it's what? Ordinary point. What's the first step? Write y as sigma c and s and y prime as this one. Do we have y double prime?
No.
Okay. What should we do now? Substitute. We substituted this. Now we need to add these two series. The powers now, both of them, they should be what?
Okay.
Okay. But remember here, these ones, when we are adding them, it's left equal right. So always on the right, what we have? So make them the same power. We made them the same power. Now the powers are the same. What do we need to have? Same starting value. What's the largest starting value? 1. We wrote it now in this way. Now we will compare the next. Okay, miss? Now, the point that in order to understand next lecture, if we have, miss, we will write it now here. Let me just check where we use talking about. Miss, when we say sigma of something x power n equals 0, this one, what does it imply? That what we have before xn is equal to 0. Do we agree? We will use this one, this note, next lecture, in order, next Thursday, hopefully, in order to understand how we continue. Any questions, miss? Hey, miss, good luck in the examination. If you have questions, please send them by tomorrow during the week, and I may not reply. So either I will reply Friday or on Monday. And on Monday, you can pass during the office hours if you have questions. Have a nice weekend.
Thank you, Dr.
Welcome, Miss. I will share the annotations on this. Welcome, Miss Steve.